Part 2 of Lewis dots and stuff. Alright, so for silicon tetrachloride, what's going to be the central atom here? Silicon, because that's the least electronegative. So silicon has 4 valence electrons. Each chlorine has 7. So you may see where this is going, and I think as you start to get practice with these, you'll sort of see and sort of make it kind of work. So that if each chlorine wants 1 more valence electrons, these guys participate in covalent bonds because they're both nonmetals. They both want additional electrons. So let's start doing it a little shorthand. You may notice that I've kind of stopped putting in all the valence electrons of the chlorine atoms here, yet each of them does have these unbonded pairs or lone pairs of electrons around it. I'm just not really drawing them there. I hope that's okay with you. So that is silicon tetrachloride. I'm going to erase it so I have some room. Alright, now what about sulfur dioxide, you may ask? Well, I will say, hey, how about this? What's going to be the central atom? Well, the least electronegative one. Remember that the kings of electronegativity and hogging electrons are fluorine, oxygen, nitrogen, and chlorine. So let's put sulfur with its, how many? 6 valence electrons. And it wants how many? Looks like it wants 2 more electrons, and as does each oxygen. Okay, so how's that going to work? Well, let's see if we can work it out. Alright, so if each one, let's see, how can we do this? Sometimes you kind of just have to kind of make them work, okay? So what we're going to do here is let's put an oxygen there, and I realize you're saying like, well, wait, is that right? And let's for now, sometimes it does sort of like you do have to just make it work, so that if you put an oxygen there and a double bond here with sulfur, that's going to give you, let's sort of do the check. One of these oxygens has a double bond, and one of them is like this. So how many valence electrons should we have? We should still have 18, and let's also just check and make sure everybody's happy. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And is each of them happy? They should all be happy. So we'll talk about how that sort of like works in a little bit, but I think for now, if you can kind of follow those rules, you'll be in good shape. So that is sulfur dioxide. All right, let's check out another one. How about some magnesium oxide? This is kind of a trick because what type of bond is this? It is ionic, because you have something that's a metal and a non-metal, something that's wants to lose electrons and something that wants to gain them. So magnesium starts with 2 valence electrons. Oxygen starts with 6. Magnesium gives up its 2 electrons to oxygen, giving it what type of a charge? Positive charge. Oxygen with the full valence shell has a -2 charge. This is an ionic bond for magnesium oxide. All right. What about for sodium sulfide? A similar type of thing, except you got sulfur. Oops. And it wants 2 electrons, so it's going to get 1 from each of these guys, and you end up with, it's sort of like this, where the ionic bond's sort of there. It still does make a crystalline structure. Bromine, I think that we've done in class. HCl and HBr are probably, they are very, very similar. Each of them should end up like this. Alright, I hope that helps. Yeah, okay, let me know if you have questions. Bye.